Hello and welcome. My name is Stephen Greider, and I'm going to be taking over for Colt for part 2 on this course. Congratulations on making it this far. Hopefully you've had fun so far and you're ready to keep learning a lot more about JavaScript. Now right away, I want to tell you that part 2 of this course is going to be a little bit different than part 1. In part 1, you were learning a lot of different individual topics around JavaScript. And you were really focused on the basic features of the language, so understanding things like objects, classes, functions, and so on. And you were, in general, not building a lot of larger apps. So in part 2, we're really going to change the structure of the course significantly, and we're going to have a very different structure. So in part 2, we're going to be covering fewer topics, but every topic that we do cover is going to be in way greater detail. So this is where you're going to really get to apply all of your newfound JavaScript skills. In addition, we're going to have a lot more focus on design patterns and some more advanced concepts and features of JavaScript. So this is a lot more about building larger applications and really giving you some experience and confidence in building your own apps. The last thing I want to mention is that as we go through this second part of the course, for all these different apps we build, we're going to be doing a lot of refactoring. The idea here is that I want to show you for every app several different ways to approach any given problem. I don't want to show you just one way and say, this is it, this is the only way to build this application. Instead, I want to give you a toolbox that you can use and a toolbox of different skills to build your own apps. Okay, so now that we have a better idea of what we're going to be doing inside of part 2, let's take a quick pause right here. We're going to come back to the next video and start to discuss the first application that we're going to be working on. In this video, we're going to start working on a new little project based entirely inside the browser. This is going to be a project focusing on just practicing some of our basic JavaScript skills, particularly classes and functions. So let's take a look at a mockup and get a better idea of what we're going to be building. All right, here we go. So we're going to be making a somewhat simple little timer application. When a user visits our application inside the browser, we're going to show them a number, like 30 right there, a play button, and a pause button. Whenever the user clicks on play, we're then going to count this timer down. So in this case, it starts at 30 seconds. After 1 second, we'll go down to 29, then 28, 27, and so on, until eventually it gets all the way down to 0. As that timer is counting down, a user can pause it at any time by clicking on the pause button right there, and then resume it by clicking on play again. Now I'm sure this seems like a very simple and straightforward application, kind of basic, kind of boring, but there are going to be a couple of elements inside of here that kind of make it a little bit more challenging and a little bit more interesting overall. So the first thing I want you to notice is that there's this circle around the timer itself. We're going to have a circle kind of like drawn around the timer element. And as this timer counts down from 30 to 27, 26, and so on, we're going to essentially revolve the timer. So you can imagine this as kind of being like a border, and the border is going to kind of fill up around the outside all the way until it gets to the very top again. Now that's kind of a bad description of what's going on, but as soon as we start writing some code, you'll get a better idea. The point is that we're going to have an animated little border around the edge of this element. The other thing we're going to do to make this just a little bit more interesting is we're going to make sure that a user can click on that number right there, and whenever they click on it, we're going to turn that thing into a text input. So a user can change the timer to, say, countdown from 10 seconds or 5 seconds or whatever else. So it's not fixed at 30 or anything. A user can change it to any time that they want. And of course, once it counts down all the way to 0, a user can then click in there, update the timer to, say, 60 seconds, and start it all over again. Okay, so although it's going to be kind of straightforward in nature, there are these couple extra things that we're definitely going to have to figure out. And the border part in particular is going to actually be kind of challenging. We're going to have to figure out some interesting stuff in the browser to really make that work. All right, so now that we've got a better idea of what we're going to be working on, let's take a pause right here and start to do some project setup in the next video. All right, now that we know what we are building, let's flip over to our terminal. We're going to create a new project directory and then start doing a little bit of setup. So I'm going to go over to my terminal. I'm inside of a workspace directory of sorts. Inside of here, I'm going to make a new project folder that I will call simply timer. I'll then change into that directory and start up my code editor inside there. Once my editor is open, I'm going to create an index.html file and an index.js file as well. We're going to put together a little bit of boilerplate inside this HTML document, so let's get to it right away. At the very top, I'll put in my doc type of HTML. I'll put in my HTML element, I'll put in a head, a body, and finally a script tag with the source of index.js. Okay, simple enough. Then inside of index.js, I'll do a quick console log that says, hi there, just so we can make sure that we correctly hooked up our index.js file to the HTML file. Once I've got all this stuff put together, I'm going to make sure that I save both files. I'll then go back over to my terminal and open up that index.html file. Once it is open, I should see a console log inside of my developer console of simply hi there. So as long as we see that, that means we are good to go. All right, some pretty straightforward setup. So now we've got this all put together, let's continue in the next video, and we're going to start to discuss how we're going to approach this project and generally architect it out. In the last video, we did a little bit of project setup, and now we're ready to start writing some code. Before we write any code whatsoever, however, I want to really quickly discuss how we're going to approach and generally architect this program. So I want to really take a look at this mockup right here and think about some of the different things that our program is supposed to do. So in total, remember we're going to have the timer and that kind of animated border around it. I would say that our program really does kind of two different things. First off, one of the core responsibilities of our program is to display that timer. So like some element on the screen that displays some number of seconds, the play button underneath it, and the pause button. That is all stuff that is 100% related to running a timer. Now separate to that is the idea that we want to show that animated border around the timer. Yes, the border is very tightly coupled with the timer, like we want to update that border animation every time the timer starts to tick down. But nonetheless, these really are two different parts of our program. One is the timer, the other is some result from that timer, or some effect that the timer has on our application. So as we start to think about what our program does, I want you to imagine how we might write out some code to implement this thing. I'm going to show you a little bit of pseudocode, or kind of like fake code inside of a diagram, to help you understand one possible way that we might implement this timer with the border around it. Now the code that I'm about to show you is not code at all. It is just a series of steps. It is not the actual implementation we're going to put together. It is just for demonstration purposes. Okay, so here's one possible implementation. So we might set up an event listener to watch for a click on that start button. And the start button, of course, is that little play button right there. So we could set up a click event listener and watch for a click on it. And then whenever a click occurs, we'll run this series of steps right here. So maybe right away, we can draw a full border around the timer, or like clear out the border or do something with it, some like initialization for that border animation. Then immediately after that, we can start counting down on the timer. So like 1 second, we'll run some block of code to update our timer and maybe the border as well. So then each time the timer starts to count down, we can take a look at the border and update the animation to kind of advance it around the outside of this circle. In addition, every time the timer counts down, we might also update the text as well. So this number right here would go from say 27 to 26, 25, and so on. Then we'll take a look at the current timer and we'll say that, okay, if we just counted down and the timer reaches 0, we probably have to do some kind of like cleanup stuff. So maybe we need to reset the border in some style. And maybe we need to also reset something around the internal timer to get it ready for another run. So again, this is just one kind of guess of a possible implementation. The reason I'm laying this out here is I want to make a really important point. I want you to take a look at the ordering of lines of code inside this block right here. And I want you to notice that between the two things that our program does, just about every other line of code addresses something very different inside of our application. So in other words, this first line right here is related to the timer itself. It is watching for someone to click on that start button. Then inside of our click event handler, the first thing we do is something about the border. Then the next line of code is something about the timer. Then it's something about the border. Then something about the timer, timer, border, timer. So as we start to think about the real structure of this block of code right here, we are essentially alternating what every single line of code does inside of this block. And that would mean that over time, this would be some really challenging code to understand, because we're going to essentially change context or change what our brain has to be thinking about as we're reading every line of code in series. So rather than taking this kind of approach right here, where we have to be considering, okay, timer, border, and so on, we should instead try to isolate all the different responsibilities of our application into different and separate blocks. So how can we do that? Because at the end of the day, we still have to say, draw the border around the timer and do the update and so on. Well, one possible way to address this would be to use a kind of evented style approach. So this is the same series of actions right here, or the same kind of layout, but rather than having right here something that is specifically related to updating the border, maybe instead of saying, hey, border, go update yourself, maybe our timer could instead emit some kind of event or emit some kind of notification to the rest of our application and say, hey, if anyone cares at all, the timer just started. And then some other part of our application can watch for that event to occur. Whenever that event occurs, we can run some code to draw the border. We can then start to count down the timer. And then every single time that we tick down the timer or kind of count it down, we could once again emit an event that signals that the timer has ticked in some fashion. So then we can write some code somewhere else inside of our application that watches for that event to occur. And when it does, we can update the border and kind of like advance it or advance that animation around the outside the circle. And then same thing down here as well. Rather than running some code that specifically says, okay, let's take a look at the border and reset it, instead, we might try to write some code that emits an event or something like that to signal that the timer is all done. And so somewhere else inside of our application, we could run some code or watch for that event. And whenever it occurs, we could reset the border or do whatever else we want. So again, the idea here is that rather than try to write some code where we are alternating what we are doing step by step, and every line of code essentially does something totally different and unrelated to what occurred before it, we can instead say, okay, let's have one block of code right here that is 100% focused on one aspect of our application. And if some other part of our app, like say the border, needs to know about this stuff, rather than directly saying, hey, border, please go update yourself, we can instead emit an event or something like that. Maybe run a callback function that says, okay, timer started, timer ticked, timer is done. And so this kind of approach right here would allow us to write some much more clear code. We would end up with an implementation of our timer that could possibly be reused between different projects or for different purposes beyond just updating the border. In addition, we would also have some implementation for updating the border that wouldn't really care about whether we are having it work with a timer or some other kind of thing, like say the progress of making a network request or downloading a file or something like that. All right, so if this diagram doesn't make that much sense right now, that's totally fine. We're going to write some code very quickly, and we're going to start to explore this idea and see how we can kind of really isolate the different responsibilities inside of our program. Okay, so now that we've got a better idea of how we're going to kind of approach this, let's take a pause right here and start working on an implementation in the next video. In the last video, we started to discuss some architecture inside of our application, and we eventually settled on saying that rather than having a block of code that alternates responsibility of just about every line, we're going to instead try to create one solid block that is 100% concerned around the timer. And then that block of code will eventually emit some events or call a callback or otherwise tell the outside world that something important just occurred. So in this video, we're going to start to focus on how we're going to actually implement this thing. How are we going to write out some code that actually does what you see right here? Well, to implement this, we're going to try to use a JavaScript class. We do not have to use a class to implement something like this, but I think that we're going to write out the code and you're going to agree with me that using a class for this timer is a really good use case. So we're going to get a good idea of how to use a class around DOM elements and how to actually do it effectively. Okay, so I sat down and thought up of a couple of different ways to design this timer class. And I'm going to share with you one way that seems kind of good to me. So this is the way that we're going to implement our timer. So we're going to make a class called timer. And this class is 100% concerned with these elements right here, the numbers, the play button, and the pause button. Class timer is not going to know anything about that animated border around the timer. Instead, class timer just knows about those three things right inside of the border. So on class timer, we're going to have a couple of different methods. These different methods are going to be invoked automatically whenever a user interacts with the timer elements, so like the numbers and the two buttons. So whenever a user clicks on the play button, we're going to call the start method. And so as you'd guess, calling the start method is going to start up some internal timer or something like that. Whenever a user clicks on the pause button, we're going to run the pause method. Remember that in order to change the timer right here, a user can click on that thing, and whenever they do, it's going to turn into a text input. And so we're going to say that whenever a user changes that text right there or changes the duration of the timer, we will call a method called onDurationChange. So that's a sign that, hey, the user just changed the duration of the timer. And then finally, we might also have a method on here called something like tick. And tick is essentially going to do what we said these steps were right here. So essentially, every single second or so, or like half a second or something, we're going to need to run some code to update the state of the timer. So like change the actual number on there and all that kind of good stuff. And so that will be done inside of a tick method. So tick is going to be called repeatedly over time as long as the timer is counting down. So this is the general idea. We're going to have a class, and certain things we click on or interact with are going to invoke different methods. Now, of course, at some point in time, we're going to have to make sure that we set up some event listeners and say, okay, whenever we click on that play button right there, we want to run the start method. So to set up these event listeners, we're going to say that our class timer is going to have a constructor function. Remember what a constructor function is. It's a very special function that gets called immediately whenever we create a new instance of a class. So we're going to say that whenever we create a class timer or an instance of timer, we're going to pass in a reference to some DOM element that's going to serve as that little text input right there. As the second argument, we'll pass in some DOM element that will serve as the start button. And finally, we'll pass in a third argument that's going to represent the pause button as well. Now, when I say duration input, start button and pause button right there, all I'm saying is we're going to write a query selector. We're going to find the text input, the two play buttons, and we're going to pass those into the constructor so that our class essentially has a handle into the DOM. And whenever it needs to reach into the DOM and do something, it will have these variables close at hand. Okay, now once again, I just want to mention that if this stuff seems a little bit confusing right now, that is totally fine. This is really your first taste of seeing how to effectively use a class around DOM elements. So the first time you see this, it always looks a little bit crazy. It always looks challenging. But I guarantee you, as soon as we start to write some code out, you're going to get a really good idea of what is going on. Okay? So let's take a pause right here. We're going to come back to the next video and start to implement class timer. All right, now that we have a better idea of what we're going to do here with this class of timer, let's go back over to our code editor and start implementing it. Again, I want to repeat that if this seems really confusing right now, no problem. I fully expect that it does. As we start to write some code, you're going to very quickly get a better idea of what we're trying to do. Okay, so I'm going to go back over to my index.js file. Inside of here, we currently have our console log of hi there. So I'll just delete that and I'll replace it with class timer. So inside of here, I'm going to first define our constructor method. Remember, the constructor is a very special function. It's going to be called automatically whenever we create a new instance of timer. So in other words, if I say down here new timer and pass in an argument of like hi there, what actually gets called behind the scenes is the constructor function. And the first argument to the constructor function will be that message of hi there. So if we receive that variable of message and like did a console log of it, I would expect to see a console log of the string hi there appear inside of our console. So for us, we're going to eventually try to pass in references to DOM elements that our timer class are going to listen into. So our timer class is going to listen for, say, a click on the start button, or a click on the pause button, or someone to change the duration input right there as well. Whenever those events occur, our timer class is going to run some method defined inside of it. So inside of here, I'm going to look at the constructor, and I'm going to receive an argument of duration input. So again, this is going to be a reference to a DOM element that is a text input. So whenever we create a timer, we are going to have to make sure that we pass in as the first argument a reference to a text input. Then our second will be the start button, and then finally, the third is the pause button. Then inside of here, we're going to immediately take these three different arguments and assign them to instance variables. So we can refer back to these DOM elements from other methods inside of our class if we so choose. So I'll say this dot duration input is duration input. This dot start button is start button. And this dot pause button is pause button. The next thing we're going to do is set up some event handlers on these different DOM elements. So as I've said many times now, whenever a user, say, clicks on the play button, we're going to want to call a start method that is defined inside of our class. So let's just start to worry about that pause, or excuse me, that play button for right now. We won't worry about pause or the text input. Let's just try to make sure that whenever a user clicks on that play button, we end up calling some method inside of our class called start. So back over here, I'm going to first define a method called start. And inside there, I'll do a console log of time to start the timer. Then to make sure that we call this method, anytime a user clicks on the start button, we could set up an event listener from directly inside of our constructor. So we'll say this.start button, add event listener. We're going to watch for a click event, and anytime that occurs, we will call this.start. And that's pretty much it. So that's how we're going to receive some arguments inside of our constructor. We're going to store a reference to each of them in case we need to work with them at some point in the future inside of all of our different methods. And then right away, we will bind some event listeners to those elements as well. And that's how we're going to eventually call some method that is defined inside of our class. Okay, so now we've put this together. Let's try to create a duration input inside of our HTML document. We're going to create a start button and a pause button. We will then create an instance of our timer class and pass in references to those three elements. So I'm going to first go back to my index.html file. Over here, I'm going to create an input element, and I'm going to give it an ID of duration, just to make it really easy to select. I'll also make a button with an ID of start, once again, just to make it easy to select. And I'll give that button some text like start. And then finally, another button with an ID of pause. I'll give it some text of pause and close off that tag as well. So now we can attempt to select each of these three different elements and then create an instance out of our timer using them. So back inside of index.js at the bottom of the file, I'm going to select those three different elements using some query selectors. We can either use a query selector or a get element by ID. In this case, I'm just going to use the query selector method because honestly, I just personally prefer to use it. You could definitely use a get element by ID if you so chose. So I'll say duration input will be document.querySelector pound duration. So remember, that is how we select an element by ID when we're using query selector. Then start button will be document.querySelector pound start. And finally, pause button will be document query selector pound pause. And then finally, we can create our instance of the timer and pass in those three elements that we just selected. So I'll say const timer is a new timer, and we will pass in duration input, start button, and pause button. All right, so now the instant that we create a new instance of the timer and pass in those three elements, our timer class is going to automatically set up that event listener for us. And then whenever a user clicks on the start button, we're going to run that console log. So right now this is some very basic interaction, but I'm sure you can start to imagine how over time we might start to implement different parts of the timer by wiring up events that are occurring to those different elements to different methods inside of our class. All right, so let's go back over to our index.html file. I'm going to refresh the page, and I'll see those three elements appear. I'm going to zoom in my screen just so you can see these different elements very easily. Just remember that as you start to look at my screen, you're going to see these elements very large, and they're only large on my screen because I'm very far zoomed in. So now to test this, we'll click on this start button, and as soon as we do so, we should see time to start the timer. So that's going to be our signal to start to run some code inside of our class that's going to start up the timer and start ticking down seconds. And every time we tick over a second, we're going to update some text representation of the timer at the same time. Okay, so we made some pretty good progress here. Let's take a pause. We're going to come back in the next video and continue working on our timer class. We've now got a starting implementation for class timer put together. Now, unfortunately, in this video and the next one, we're going to have to go into a very quick side topic. This side topic is something that's a little bit painful in JavaScript, but that's why we're going to go over it right now before we get too deep into this application. So the little issue that we're going to discuss is around the value of this inside of a class. This is something that was covered earlier on inside this course, but I'm just going to give you a very quick reminder right here because it's going to be very relevant for us as we develop our timer class. So I want to first begin with a quick demonstration. I'm going to find my start method. I'm going to remove the console log inside there, and I'm going to replace it with console.log this, like so. Now remember, our start method is going to be invoked right now whenever we click on the start button, because we wired it up with an event listener. So that is one way in which we can invoke the start method. I'm then going to go down to the bottom of the file, right after we create our timer class, and I'm going to call timer.start directly as well. So there are now two ways in which the start method is going to be invoked. It's going to be called one time automatically when our application first loads up inside the browser. It's going to be called a second time whenever we click on the start button directly. Now I want you to recall that in general, we want the value of this inside of a class to be equal to the instance of the class that we create, because this is how we refer to different instance variables and methods that are defined inside the class. So let's save this really quickly. We're going to go back over to our browser. I'm going to refresh the page, and right away I'll see the first console log. So that is from the method call that we added down right here. So when we call timer.start, the console log of this that we see is the instance of the timer class we created. This is the result that we want in general. We always want a console log of this to result in the instance of the class, because this means that we can access the different instance variables that we defined on the class and the different methods as well. So this right here is a very good result, and that is what we always want to see. However, if we try to invoke start using this other way of invoking it by clicking on the button, we're going to see a very different result. So I'm going to find the start button and click on it. And when I do so, I'll see a console log of the button we just clicked on instead. So that means that the value of this inside of the start function, whenever we click on the button, is very different than if we just call start directly through the instance of the class that we created. This is a very bad thing. Seeing this console log right here, that is not good at all, because it means that whenever a user clicks on that start button, we will not have access to any of the instance variables inside of our class or any of the methods as well. Let me show you a quick demonstration of why this is so important. Right after the start method, I'm going to define a new method. I'm going to delete this very quickly. This is just a quick demonstration. I'm going to define a new method called important method to call. So we're going to imagine that this is a really important method that we have to call whenever start gets invoked. So then inside of start, I'm going to try to call that method. So I'll do important method to call, like so. And then maybe just to make sure that we do successfully call it, I'll add in a console log of like important thing was done. Okay, so let's now try to save this. We're going to go back over and refresh the page once again. And I made a typo. There we go, important method to call, my mistake. I'm going to save that again, refresh. That's better. So now whenever we call the start method directly through the code that we have right here, we have access to all the other methods we defined inside of our class. Once again, this is good. This is what we want. However, if we try to click on the start button, we will see an error. And that is because when we click on the start button, the value of this inside of start is going to be different than if we just called start directly. So again, this comes back to the idea of the value of this inside of a class. So in order to fix this up, and in order to make sure that we can actually use a button like this right here with an event listener to invoke the different methods inside of our class, we need to make sure that the value of this inside the start method is what we expect it to be. And for it to be what we expect it to be, we need to get a better understanding of the value of this inside of a class. So let's take a quick pause right here. When we come back to the next video, we're going to get a quick review on how we can determine the value of this inside of a class and how we can change the value of this if required. Because in this case, it definitely is required. So quick pause right here, and we'll continue in just a moment. In the last video, we recapped on why the value of this inside of a method inside of a class is so important. If we ever want to call some other method inside of a class, or reference some instance variable or whatever else, the value of this must be set equal to the instance of the class. Right now, when we call this.start from our button event listener, the value of this is not what we expect it to be. It has been overridden, and the value of this inside that method is instead equal to our button that we are clicking on, which definitely doesn't have a method called important method to call. So we need to essentially make that error message right there go away. So to make that go away, we're going to review the 3 different ways that we can determine the value of this inside of a method. So let's get to it. Let's review those 3 different ways. Okay, so the way that we're going to interpret this diagram right here, whenever we want to determine what the value of this is going to be inside of a function, we're going to ask ourselves this question first. We're going to ask ourselves, did we define the function with an arrow function? If so, that is the answer to what the value of this is. If this is not true, we're going to move on to question 2. If that is not true, we're going to fall down to the kind of all other cases category here. So essentially, we go down the list and we stop at the first place that we can answer yes to. So let's first review what it means to use an arrow function and what the value of this inside there will be if we do use an arrow function. So if we define a function with an arrow function, and then we access this inside that arrow function, here's what we can determine what the value of this will be. We can use a little trick. So right above our arrow function, we're going to find the first valid line and write console.log this on that first valid line. Then the value of this inside the arrow function will be equal to whatever was console logged from that console log that we added in. Let me give you a very quick demonstration of this, because this rule will actually make a lot of sense once you see a practical demonstration of it. Okay, so back over here, I'm going to go down to the bottom of the file, and we're going to write out a couple of examples really quickly. First, I'm going to comment out timer.start, so we don't get any kind of erroneous console log messages that will kind of throw off this demonstration we're going to do. So then down here, I'm going to write out an arrow function called print this. And inside of here, I bet, as you would guess, we'll do a console log of this. So now here's the question. What is the value of this going to be equal to inside of here whenever we call print this? Well, if we want to determine what this console log will result in, or what the value of this is, we can take a look at the arrow function. We're going to find the first valid line of code above the arrow function. So that would be like this right here. That's the first valid line. And right there, we will add in a console.log of this. So now the value of this inside the function is going to be equal to the value of this outside the function. These 2 console logs will be absolutely identical. And so we could check that by calling print this. I'm going to save this file, flip back over, refresh, and we'll see that in both cases we get window, which is essentially the global context inside of JavaScript when we're executing code inside the browser. So this definitely means that this first rule worked out correctly. Let's take a look at a little bit more complex example of how to use this little trick around arrow functions. So I'm going to define a new object that I'll call, how about colors? Inside of here, I'm going to define a method called print color. And then we're going to eventually inside of here define a function called print this once again. And inside there, I'll do a console.log of this. And then immediately after it, I will run print this. So now once again, in order to determine what the value of this is going to be inside there, we could add a console log on the line right above. So right above the arrow function, I'm going to add in console.log this. And once again, the value of this is going to be identical between those 2 console log statements. Let's first comment out that little block right there and just run print color by itself and see what the console log normally would be. So down here, I'll do colors.print color. I'm going to save this, flip back over, refresh, and so normally the value of this inside of that method would be the object itself, like the entire object that we just created, this colors object. So that means that inside of that arrow function, the value of this is going to be equal to the colors object as well. So I'll save this now with all that stuff uncommented, refresh, run it again, and we'll see the identical console log in both cases. Okay, so again, that is the rule for determining the value of this inside of an arrow function. So let's now take a look at the second way, or kind of if we don't define a function with an arrow function, how then do we decide what the value of this is going to be inside there? So the second check we're going to do, we're going to see, did we call the function with bind, call, or apply when we invoked it? As a quick reminder, bind, call, and apply are built-in functions that belong to all functions inside of JavaScript that we create. We can use bind, call, and apply to call a function in a very special way. The first argument to all 3 of bind, call, and apply is going to be the value of this that we want to execute the function with. Now this note right here is really confusing, so let's just write a real quick code example right away. I'm going to delete the colors example, and I will replace it with a new function that I will call print this, and this time I'm going to define it with a function keyword, because if I defined it with an arrow function, then we would use that rule instead of the second one. So then inside of here, I'll do a console.log of this as usual. And now I'm going to invoke this function right here by using call. So I'm going to call print this. I'm going to invoke it using call instead of calling it directly. And now the first argument to call right here is going to be the value of this inside of the function. So I'm going to put in here, how about a object with a color of red. So now when print this gets executed, the value of this inside of it is going to be equal to that object right there. So I'll save this. I'm going to go back over, refresh, and sure enough, there we go. So again, if we make use of call, first argument is going to override the value of this inside there. We can do the same thing with apply as well. So I'll save this as well, refresh, we get the same exact result. If we don't call the function with apply, so if we just call the function directly, the value of this is going to be a little bit more unpredictable. So let's refresh, and we see that in this case, it is equal to the window. So again, it is very clear that if we call the function with bind, call, or apply, that is going to override the value of this inside the function. So that is the second check that we always do. So now we fall on to the last case here. If we don't define the function with an arrow function, and if we don't use bind, call, or apply, we fall into all other cases. And in order to determine what the value of this is going to be inside the function, we take a look at where we invoke the function. We take a look at whatever is to the left of the dot inside of the function call, and that is what the value of this is going to be equal to. Now this is another scenario where the note I have right here is a little confusing, so let's do a quick example again. So I'm going to delete this example. I'm going to create a new object again called colors. Inside of here, I'll make a method called printColor. And inside there, I'll do a console log of this. Now, how would we run the method printColor? To run that method, we would call colors.printColor. So now here's the trick. We're going to take a look at these rules right here to determine what the value of this is going to be inside of this function when we call it. So we first say, do we have an arrow function? Nope, definitely don't. Are we calling the function with bind, call, or apply? Nope, definitely not. Okay, so we fall into this other case right here. So in order to determine what the value of this is going to be inside of this function when we call it, we take a look at the period to the left of the function name, that period right there, and we look at whatever variable is to the left of it. In this case, the colors object. Because the colors object is to the left of that period, the value of this inside of printColor is going to be equal to colors. So this right here is what this is going to be. So let's save this, and we can verify that really easily. So I'll refresh again, and sure enough, I see printColor. We can really abuse this rule right here to really demonstrate how it works very easily. So let me give you a quick example. I'm going to create another object right underneath colors, and I'll call this one like random object. And I'll give it a property of like A is 1, like so. I'm then going to assign random object a new property called printColor. And I'm going to assign to that property right there the printColor function from the colors object. So I'll say colors.printColor. Now notice here, I am not calling printColor. It's not being invoked. I'm just taking the function and assigning it to the random object on a property called printColor. So this line of code right here is equivalent to if I just copy pasted that function down like so. Totally equivalent. So let's now try to call randomObject.printColor. So randomObject.printColor. So now we're going to define a method that is defined inside of the colors object. But what this method is defined inside of doesn't govern the value of this inside the function. Instead, the rule that we fall into is this one right here. And to determine the value of this inside the method call, we take a look at whatever is to the left of the dot when we invoke the method. So here's when we invoke the method. We're going to take a look at the dot, and what is to the left? It is random object. So now when we call a print color right here, we're not going to see a value of this being console logged, that is the colors object. Instead, we're going to see the random object. So I'll save this, go back over to refresh, and there we go. We see a console log of the random object, not the colors one. Okay, so that is it. That is our 3 big rules right here. This is how we determine the value of this. So now the inevitable question is, how does this solve our problem, right? How are we going to fix the issue we have where we need to call start and have it always give us the same value of this? Well, in order to make sure that we can enforce the value of this inside the start function, we're going to just simply make sure that we fall into case 1 or 2. So in other words, in order to make sure that the value of this inside of start is always the instance of timer that we want it to be, we're going to define that function using an arrow function, or we're going to call it using bind, call, or apply. So that's how we're going to fix this problem. Let's take a quick pause right here because this is a very long video. We're going to come back to the next section or next video and wrap all this stuff up rather quickly. So quick pause and I'll see you in just a minute. Now that we've taken a look at the 3 different ways to determine the value of this, we're going to use this knowledge to fix up our scenario. So we're going to make sure that the value of this inside the start function is always what we expect it to be. So the first way that we can solve this is by making sure that we define the start method with an arrow function. Right now, the syntax you see right here, behind the scenes, this actually gets translated into a normal keyword function that looks like that right there. So this is what happens behind the scenes. So right now, we are not making use of an arrow function to define start. If we wanted to use an arrow function right here, we would put right after start equals, and then between the parentheses and the curly brace, we would put in our arrow like so. So this is going to define an arrow function and assign it to start. So now we can use our rule back over here to determine what the value of this is going to be inside this function. But there's a little caveat. This rule does hold, but if we follow it to a T, the first valid line above our arrow function, this is not a valid line to put right here. We can't do a console log of this right here. That's why I said valid inside this diagram. So we cannot put a console log right here. Instead, the first valid line above this arrow function would be outside of the class, like up here. Now normally, if we do a console log out here, we're going to get a console log of window because we're essentially inside the global scope. So in this case, it would seem like this rule falls apart. You would think that this rule does not actually hold, but it does, because there is a little trick. When we write out code like this right here, we are using an advanced feature of JavaScript called class properties. Behind the scenes, JavaScript is going to take this function declaration right here, and it's going to move it out of the class. We can actually see this in action if we take our class definition and run it through a tool you can find online called Babel. Babel takes very modern JavaScript syntax and converts it down to much more basic or simplistic JavaScript that can be ran or executed inside of older browsers. It turns out that a lot of the syntax we're using right now relies upon newer features of JavaScript that are not supported in older browsers. And so tools like Babel just make sure that these very modern features that we're using can still be executed safely inside of an older browser. So I'm going to take the code that we just wrote. I'm going to take this class right here. I'm going to copy it, and I'm going to throw it into this Babel tool. So I'm going to put my code on the left-hand side, and I'll see some output come on the right-hand side. So this is what would actually be executed inside of an older browser. Or put another way, this is how JavaScript kind of interprets our code at a more basic or simplistic level. So take a look at this. When we define this start method using this class property syntax, because that's what we're using right here, it turns out that we're not actually defining an arrow function inside of the class body. Instead, the browser and this Babel tool is going to massage the code that you wrote. It's going to take that function declaration and move it into the constructor. So this right here is the code that actually will be executed inside of a browser. So this is what is really truly going on behind the scenes. And once we see this, you'll notice that our rule back over here still holds 100%. Take a look at the constructor. Inside the constructor, we define an arrow function. So now we can take this code right here and apply the original rule to it. I'm just going to do a quick copy paste back over here just so I can edit it very easily. So this is what actually executes inside the browser. And so if we want to figure out what the value of this is going to be inside the arrow function, we're going to go to the first valid line of code above the function declaration. So that would be right here. And we would then do a console log of this. And whatever comes out of this console log is what the value of this is going to be inside the arrow function. And so because we're in the constructor, we are always guaranteed that the value of this is going to be equal to the instance of the class. And so the value of this inside the arrow function is going to be equal to the instance of the class. So that's a secret behind solution number 1 that we have right here. If we use an arrow function, this rule back over here still applies. And that's how we can fix the value of this inside the start function. Now just to prove that, I'm going to go back down to the bottom of the file. I'm going to delete all this extra test code that we put together down here. And I'm going to delete the timer.start line as well. That was just a quick demonstration. I'm then going to save this. I'm going to go back over to my browser. I'm going to refresh the page. And now I'm going to click on the Start button again. And now we can see that the Start button works as expected. We were able to call a method defined on the class. We could also, if we wanted to, reference instance variables as well. So again, this is solution number 1 right here. So in order to get the value of this inside the start method to what we want it to be, we just use the first rule right here. So now let's take a look at how we would use method number 2. So if we want to do method number 2, we could call bind on our function, which will override the value of this inside of it when it actually gets called. This method is a little bit more advanced. We are not going to use this method just about anywhere inside this course. I'm only mentioning this way of fixing the value of this because you will see older projects, older code that uses this style. So with this approach, we could refactor our start method back to how it was before, like so. And then we will find where we pass our this.start function off to the event listener. And then on start, I'm going to call .bind this, like so. So when we call .bind this, unlike call and apply, which invoke the function right away, bind instead returns us a new function that we can call at some point in the future. So calling bind, it doesn't run start right away. We're still passing a function off to the event listener that's going to be executed at some point in the future when a user actually clicks on the button. But with bind, very similar to call and apply, we pass in the first argument to bind, and that is going to be what the value of this is forced to be inside of the start function. So now the value of this inside the start function is going to be forced to the value of this out here inside the constructor, which is always, once again, going to be equal to the instance of the class, which is what we want it to be. Okay, so let's save this. I'll do a quick test again. I'll refresh, hit start, and once again, I see important thing was done. Okay, so that's it. Those are the 2 very easy and most common ways that you're going to see to fix the value of this inside of a class. So again, we're going to rely on the first solution right here because it is definitely the more modern way and it's what you're going to see more frequently moving forward. So I'll define the start function using the class property syntax like so. I'm also going to remove the .bind over here and restore it to just that. Finally, I'm going to clean up the important method to call. That was just a very quick demonstration. Okay, so again, I apologize for these 3 videos of going over a topic that was covered earlier. Maybe this stuff was really challenging, confusing, all that kind of stuff. The reason I went over it was just to show you a more practical example than what you might have seen earlier inside the course. And of course, I'm showing it because this is going to be very critical to how we put together our timer class as well. So now that we've got this stuff all under wraps, quick pause right here. We'll continue working on our timer class in just a moment. All right, so now that we've got all this stuff out of the way, let's get back on track. We're going to focus on our start method right here. So the goal of our start method is to start up a timer. We want to make sure that we run some amount of code every some amount of time that's going to be responsible for updating the text inside of our timer. So like count the 19 down to an 18, 17, 16, and so on. So the code that is going to actually update the timer itself and like count that thing down is going to be placed inside of this tick method. The goal of the tick method right here is to update the text inside there and eventually emit a signal to the rest of our application to say, hey, some amount of time just passed. So the goal of start is really just to start up the tick method and call it every so many number of seconds. So let's take a look at what the implementation will look like. Right underneath start, I'm going to also define tick, and I'm going to use that same kind of arrow syntax like so. Inside of tick, I'll put a quick console log of tick just so we can make sure that we're calling it appropriately. And then inside of start, in order to make sure that we call tick every so many seconds, like every second or so, we can use the set interval function that is built into the JavaScript language. So inside of start, we will invoke set interval. We're going to pass in a reference to a function to invoke, which will be this.tick. And then as a second argument, we'll put in how often we want to run this function. So in this case, I want to run tick every 1 second. The second argument is expressed in milliseconds. There are 1,000 milliseconds inside of a second. So this code right here is going to make sure that we run this.tick once every second. So the net result should be seeing a console log every second inside of our console. All right, so let's save this, flip back over, and see how we do. So I'm going to refresh. I'll click on start, and then I see tick, 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 and so on. Okay, well that definitely looks good. But there is a very subtle little issue here. If we refresh again, I want you to notice that when we click on start, we have to wait a full second before we see the first tick. So it turns out that when you call set interval, it's going to wait 1 second, or whatever that delay is, before calling that function for the first time. In our application, this would be kind of bad, because whenever a user clicks on that start button, they really expect to see the timer start working right away. We don't want them to be waiting around for a second and then see some kind of update. Instead, we want that update to occur instantly. So in order to make sure that occurs, we're going to simply call this.tick manually right before. So now this is saying whenever we call start, we're going to immediately run 1 tick. Then we're going to set up an interval that's going to be executed 1 second in the future, and then 1 second after that, after that, after that, and so on. So if we save this again, go back over, refresh, and click start, we now instantly see tick, and then tick, 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 and so on. Okay, so that looks pretty good. Now this was pretty easy, so let's just keep going right now. The next method that we need to put together is the pause method. So we need to make sure that when we click on that pause button, we stop the ticking altogether. In order to stop our interval, essentially stop this function from being called, whenever we call set interval, we get back something called a timer. So I'm going to assign it to a variable that I'll call timer, like so. And for right now, let's just do a console log of that timer and see what exactly it is. I'll go back over, refresh, click start again, and there's the console log of the timer. So in this case, it is a simple number of 1. Let me tell you what's going on behind the scenes. Whenever we call set interval, we get back an integer. The integer is an ID, and it's essentially representing the running timer or the running interval that is going to continue executing this function again and again. If we ever need to stop that timer or stop this interval from running, we can call another function that is built into the browser or into JavaScript called clear interval. When we call clear interval, we're going to pass in the ID of the interval that we want to stop. And so in this case, it would be the timer variable right there. So in this scenario right here, we are essentially setting up an interval and then immediately canceling it. So I would expect to never see the tick function run except for the first time we call it manually right there. So let's save this again. I'm going to flip back over, refresh. I'll hit start. And so now I see 1 tick. Behind the scenes, we set up our interval, and then on the next line of code, we immediately canceled it. So I don't see any more ticks up here. So of course, rather than canceling the timer right away, well, we probably want to cancel it at some point in time in the future. Specifically, in our case, whenever the user clicks on the pause button, which should run the pause method inside of our class. So let's define a pause method. We're going to make sure that the pause method is going to call clear interval and pass in the relevant ID. So underneath start, I'm going to define my pause method, like so. Inside of here, we will call clear interval. Now, there's just a little issue. We need to somehow get the timer variable that was created over here into this other method. In order to share information between different methods, we assign that information to an instance variable. So instead of assigning it directly to a variable right here called const timer, we're going to say this.timer. So by assigning the value to this, that's going to make sure that we can refer to this.timer over inside this method, and we'll get access to the same information that we just assigned right there. So in other words, we're going to say clear interval with this.timer. We can also clean up the clear interval that we left inside of start because we don't need it inside there anymore. Now, one other quick thing I want to mention. we are currently working on a class called timer. Referring to a variable inside of here of like this.timer is just a little bit unclear because we now have two words inside of a class that are really, really similar. So in order to avoid any confusion whatsoever, I'm just going to change the name of the variable that we are assigning the ID to how about interval? Because that's kind of what it represents. You could also do something like interval ID. That would also be appropriate as well. But I'm just going to go with interval. That is what I use personally on projects that I work on. I'm going to make sure that I update this.timer inside of pause as well, like so. Okay, so now to test this out, last thing we have to do very quickly, we need to make sure that back up inside the constructor, we watch for a click event on the pause button element. Whenever a click event occurs, we need to run that pause method. So right after where we set up our click event handler right there, I'm going to do a this.pause button add event listener. I'm going to watch for the click event. Whenever that occurs, I want to run the this.pause method, like so. Okay, so it looks pretty good. So I'm going to save this, and we'll do a quick test. So I'll flip back over, refresh, I'll hit start. Now we're going to see a tick once every second. And then as soon as we hit the pause button, it stops. And so I don't see any more ticks occur. All right, well, let's say that this is working out pretty darn well so far. So let's take a quick pause right here and continue in just a moment. Okay, our class timer is looking pretty good. Believe it or not, our start and pause methods are just about complete. We're not going to really add any additional code to them. So we're now going to start to focus our attention on the tick method right here. Remember, the tick method is going to run once every second because we set up the interval to call it once every 1,000 milliseconds. So inside of the tick method, we're going to start to want to figure out what we want to do every second. Well, I think that every second there's probably going to be a pretty obvious thing we want to do. We probably are going to want to reach into the DOM, find whatever the current time is right there, and subtract 1 from it. So if we start off with 18 seconds, and then the tick method runs, we'll probably want to decrease it down to 17, then 16, 15, 14, 13, and so on. I want to remind you really quickly that this input, or excuse me, this element right here that's going to display the current time is actually going to be a kind of invisible text input. The reason we're making it a text input is so that a user can very easily reach inside there and change the current time or the duration of the timer. So they could enter in 300 and then hit play, and that would count down our timer from 300 seconds. So now in this video, I want to focus on a really interesting question. Well, at least it's interesting to me, I suppose. The question I want to focus on is inside the tick method. We clearly, at some point in time, are going to have to write some code that looks like this. This is going to be pseudocode. Don't write this. Just a quick example. So we're definitely going to have to write out something like time remaining is time remaining minus 1. Something like this to count down our timer from whatever the current time is, subtract 1 second, and then update the variable or the value of time remaining. So we're going to have to write out a line of code that looks like that. But here's the interesting question, and this is what I want to explore in this video. Where does the variable time remaining live? In other words, where is this data actually being stored? There's two kind of obvious or different ways we can solve that. Let's take a look at a diagram and understand the two different places that we can store the information about how much time is remaining on our timer. So the first way is kind of a slightly more obvious one, I think. And this is where if I like really grilled you and asked you to figure this out, this is probably what you might come up with. So in option number 1, in deciding where to store the time left on our timer, we might decide to create an instance variable on our timer instance called something like time left. Then every single time the tick method ran, we could subtract 1 from that value and then take that value and update our text, or excuse me, our input element with it. So in other words, when we run tick, we'll count down 29 to 28, then take the value of 28 and throw it into the input element. So some code that looks like that might look like this. I'm going to very quickly write it. I'm going to delete this code very quickly so you don't have to write this as well. So we might write out inside the constructor something like this.timeLeft equals 30. So whenever we create a class or an instance of timer, our default value for time left will be 30, representing 30 seconds. Then inside of tick, we could do something like this.timeLeft is this.timeLeft minus 1. And then we could do something like take our input element. Remember, we've got a reference to it right there, duration input. So we could say this dot duration input dot value is this dot time left. So again, take the current time, subtract 1 from it, then take that value and throw it into the duration input. And that would update the text on the screen. So this is a definitely way that works. Without a doubt, this is a method that works. Now I'm going to delete this code really quickly, and we're going to take a look at option number 2 for where we store this data. So in option number 2, we're going to kind of invert this control flow. Rather than having our timer instance have some definition of what the time left is and store it inside the input element or update the input element, we're going to instead have the current time live inside of the input element. So whatever the input element's value is, that is the time remaining. And then at any time that our timer instance needs to know how much time is remaining, it will reach into the input element, figure out what the current value is. So we're going to essentially take the value out of that input element and bring it back over to our timer instance. So why would we ever go with this approach right here? Approach number 1 seemed like it was kind of obvious. Of course, we've got a timer instance. It's got some time left. It's an instance variable, really easy to get at that value right away. So why would we ever use this approach right here? Well, the reason that we might use this approach is that it makes some UX or some actual interactions with the user a little bit easier to handle. Remember, at some point in time, we want the user to be able to type in a new text value inside this input right here. So we want them to be able to click in there and type in give me a timer that counts down from 10. If we were storing all of our data inside of our class, we would want to set up an event handler and watch for any time a user changes that value. So if a user changes that from 300 down to 10, we would have to have an event listener that watches for a changed event on that input. When that occurs, we would have to take that change value and go and update our time left. But with this approach, we don't have to worry about any event handlers at all on that input element. Because anytime we want to figure out what the current time remaining is, we can just reach directly in, get that value, pull it back out, and make use of it inside of our timer instance. Now that sounds like a very small and simple thing, but I just want to suggest that's maybe one reason that we would want to just have our timer instance store the value or the time remaining inside of that input element. There are going to be some other interactions that get a little bit easier as well when we start to take this approach, but they're not going to be quite as obvious until we get a little bit further along with this application. Now, just at a higher level, I want to mention that option number 2, we refer to this as storing our data inside of our DOM. So our application has some critical data that is required to make it work correctly, and we are storing that data inside of different DOM elements. With option number 1, we're storing all of our data inside of our JavaScript code. So we've got a JavaScript class right here. That class, or that instance of the class, has the data that is critical to making our application work. Now, option number 1 is a little bit more popular these days, right? To be totally honest with you, option number 1 is definitely more popular these days. Option number 2 used to be really popular. So years ago, this used to be the way that we wrote JavaScript applications, but it's definitely pivoted towards option number 1 more recently. Having said that, we're going to use option number 2 inside this application. And the reason for that is I want you to see what this approach looks like. I want you to see some of the downsides. I want you to understand why we used to write code like this as JavaScript engineers years ago, and why we now instead use option number 1 and store data inside of our JavaScript code instead. So I'm sorry to kind of show you not the most modern or technically correct way to do this stuff or what's really popular right now, but again, it is important for you to understand why we take one approach over the other. And the easiest way to do that is to write out the code in that older approach so you can see some of the problems that start to arise. Okay, so with all this in mind, let's take a quick pause right here. When we come back in the next video, we're going to start to update our class and make sure that it can very easily read some data out of that input element to figure out how many seconds are left on our timer, and then make sure that whenever our tick method gets called, we're going to update the value of that input element and subtract 1 from it. So quick pause right here, and I'll see you in just a minute. Okay, so in the last video, we had a long discussion about where we're going to store data inside of our application. So again, we're going to store the current time inside of that input element. That is going to be our source of truth. That is really going to be the only place that has any information about what our current timer is. So in order to actually get some value inside there and update it over time, I'm going to first go over to my index.html file. Inside of here, I'm going to find that input element, and I'm going to give it a value property. And I'll start it off as 30. Now, whenever we assign an HTML attribute, it always has to be a string. So notice how this is a string that says 30. So we just need to keep that in mind. As soon as we start to read a value out of this text input to figure out how much time is left on our timer, we're going to get a string, and we're going to have to convert it into a number. I'll then go back over to my index.js file. So over here, I'm then going to go down to my tick method. I'm going to delete that console log of tick. And inside of here, I'm going to add in some code to reach into the text input. I'm going to get the current value out of it. We're going to subtract 1 from it, and then throw that updated value back inside the input. So to do so, we're going to first get a reference to the text input. Remember, we already have a reference to it inside of our class as this.duration input. That was one of the arguments to our constructor. So inside of here, I'll say time remaining is going to be this.duration input.value. Now the value right here, once again, that is going to be a string. So we have to take that string and turn it into a number. To do so, we're going to wrap that thing inside of parse float. The parse float function is built into the JavaScript language, so we can just freely reference it at any point in time. This function is going to take a string that contains a number, and it's going to pull out just the number part of that string and give it back to us. There are two functions that do this kind of operation. There's parse int and parse float. Parse int is short for parse integer. Parse int will give us a number that does not have a decimal, whereas parse float will give us a number that has a decimal. So just as a quick example, if we have some string that has like 10.1 inside of it, and we ran it through parse int, that would give us 10. If we ran it through parse float, that would give us 10.1. So we're going to use parse float because we're going to eventually support decimals inside of our timer. Okay, so after we get our time remaining, we can then do a update to the value of time remaining and give the new value or throw the new value back into the input element. So we can say this.duration input.value is going to be time remaining -1. Okay, and that should pretty much be it. So let's now go back over to our browser. I'm going to save both these files and test this out. So I'm going to refresh over here. I can now see the default value of 30, which I set inside the HTML file. I'll then click on Start, and I'll see the timer start to count down. So now the very good thing about this approach, or kind of the nice thing, if I click on Pause right here, and I update that value to say 300, and then click on Start, my timer is just going to work right away the way I expect. We did not have to add in any additional event handlers to watch for a change event and change some internal representation of that timer inside of our timer instance. That's what we would have had to do to get a change to work correctly. You and I would have had to set up that event listener, watch for a change to the input element, and then throw that updated value back inside the timer instance. So again, nice thing about this approach, a little bit less work from the get-go. Okay, so this definitely works, but let's take a quick pause right here. And I want to point out something about the current state of our code inside the tick method. We're going to figure out some way to kind of condense the code we have inside of here just a little bit. So quick pause, and I'll see you in just a moment. Our tick method definitely works, but I want to point out something kind of awkward about it right now. Right now, in order to figure out what the current value of our time remaining is, we're going to always have to run that chunk of code right there. At present, inside of our tick class, or excuse me, our timer class, this is the only location where we really need to figure out what the current time remaining is. However, in the future, we might have many different methods inside of our class, and each of those different methods might need to access the current time. And so they would all have that little repeated piece of code right there. The same thing is true of updating the value inside the input as well. Every single time we want to update the value, we have to reference this.duration input.value, which again starts to get just a little bit old pretty quickly. So in this video, I want to try to extract that little expression right there where we get a value out of our text input and parse it with the parse float method. And I want to extract out that part right there where we set the value of our duration input as well. So to do this, we could define two helper methods inside of our class. We could say something like getTime or getTimeRemaining or something like that. I'll go with getTime. And we could also define setTime as well. So inside of getTime, we could do something like return parse float this dot duration input dot value. And on setTime, we could receive some new time and then set that inside of the duration input, like so. So this is definitely an approach that would work. Anytime we want to get our time, call that method. Anytime we want to set it, call that method. And we no longer have to worry or remember at all about how we actually get a value out of there. But rather than using these two functions, there's a little bit better way of handling this by using a feature inside of our JavaScript classes. So the better way of handling this is to use a getter and a setter method. Well, let's figure out how those work. So I'm going to delete those two methods. And I'm going to set up a getter and a setter for a new property that I'm going to call time remaining. So I'm going to say get time remaining. So notice how I've got a keyword in front of the method name. So inside of here, we're going to write out the code that's going to get the time remaining out of our duration input. So I will return parse float this dot duration input dot value. So now because we have the get keyword right here, in order to run this method, rather than saying something like back up inside of tick, we're going to eventually replace that right there, so I'm just going to delete it right away. So rather than saying this dot time remaining and calling it like a method, because the get keyword is right here, we can instead treat this as though it were an instance variable. So we can just say this dot time remaining. That is going to automatically invoke this function right here, even though we don't have the parentheses on the end. The reason it gets invoked is because of that get keyword. We set up a getter. This is how we add in some logic that's going to essentially retrieve a variable inside of our class, and we don't have to call a method or anything like that. So this might seem like a very small difference. Like at the end of the day, what is the difference between putting on time remaining with the parentheses and not? Well, the difference is that when we are able to write out just this dot time remaining, it makes it kind of a little bit more clear to other engineers, or we kind of trick other engineers, another way of putting it, into thinking that we are just retrieving a instance variable or like a property of the class. And we are essentially hiding away all the confusion about what is really going on with trying to get some value out of that input inside of this getter. So we could even like collapse this thing right here, and we could forget about the implementation entirely. And as far as another engineer is concerned, as they read this, they're just going to look at this and think, oh, okay, there's like a time remaining instance variable. And they won't have to worry about the fact that this actually technically is a function or anything like that. So now we can use a very similar approach. We can set up a setter to change the value inside the input. And once again, we can essentially hide away all the complexity around actually setting the value as well. So I can say set time remaining. So we're going to call this with the updated time. And inside of here, we'll have the same implementation we had before. So we'll say this dot duration input dot value equals time. So now to make use of the setter, we can just attempt to set a value to the variable time remaining. So back up here, rather than saying this dot duration input dot value, we could instead just say this dot time remaining equals time remaining minus 1. So in this case, we are attempting to set a value, or essentially assign a value to the value or to the property time remaining. Time remaining is actually technically a function, but again, because we put the set keyword inside of here, when we assign a value to it, whatever this value is right here is going to be automatically provided as the argument right here of time. And so again, we're essentially going to hide away all the complexity around how we actually update the variable time remaining inside of our class. So now in total, this entire tick method can be condensed down to just this dot time remaining equals this dot time remaining minus 1. So again, behind the scenes, we are calling the getter right there to retrieve that value, and we're calling the setter right here whenever we want to update the value. And I can't say it enough, I'm going to say it for like the 4th time inside this video, we have hidden away all the complexity on how we get at that value and how we set it. Okay, so I would definitely say this is a big improvement. and this is another good reason. In this particular case, again, this is not super popular approach these days, but it's a good reason to go with option number 2. Because one of the reasons that in the past, we as JavaScript developers kind of moved away from option number 2 is that we always had to write out some really confusing code like this right here and this right here in order to update values inside the DOM whenever we are storing values on DOM elements. But because we now have access to getters and setters, which are a newer feature inside of JavaScript, we can write out methods that look like this that makes storing this data a lot easier than it had been in the past. Okay, so let's save this. We're going to do another quick test. So I'll flip back over, I'll refresh, hit start, and we are still counting down successfully. I can pause again, update the value, hit start, and it still works correctly. Okay, so this is definitely looking pretty good. Let's take a quick pause right here and continue in just a moment. There's really just one last thing we have to do to implement our timer. So back inside of our browser, I'm going to change the timer down to just 3 seconds and then start it up. So I'll see that it's going to count down to 0, but then continue into the negatives. So to finish up the timer aspect of this application, all we have to do is add in a check to stop the timer automatically whenever it hits 0. So I'm going to implement that inside my tick method. So inside of here, I'm going to say if this.time remaining is less than or equal to 0, then let's call this.pause to stop our tick method from continuing to be invoked once every second. Then inside the else case, so if this.time remaining is greater than 0, then we're going to run the original let's subtract 1 second. So I'm going to cut that and put it into the else case like so. Okay, so I'm going to save this. I'm going to go back over, we'll do a quick test. So I'm going to just change this down to 3 seconds. So go 3, 2, 1, 0, stop. Okay, so that definitely looks pretty good. All right, well that's pretty much it for the timer aspect of this thing. So now we need to start to pivot our focus a little bit and figure out how we're going to get that animated border to display around this. So remember, we want to have some kind of like border that's going to either fill up over time or count down over time. We want that thing to update with every tick of a second. The other thing I want you to remember is that we still have to do a little bit of work on our timer class because we want to make sure that during these very critical stages, like whenever we are starting up the timer, whenever a second counts down, or whenever the timer ends, we're going to make sure that we watch or emit an event or call a callback or something like that. So stuff outside of our timer class can kind of hook into or watch for that to occur and then update the actual border animation. Now, one thing I want to focus on right now, or just mention really quickly, is that our current implementation of the timer class is like really simple and pretty darn straightforward. So you can take a look at this thing and really very quickly understand what is going on. If we started to add in all that border updating code into this class right now, well, our timer class would start to get really confusing really quickly, much harder to understand than it currently is. Okay, so quick pause. We're going to come back in the next video and start to implement the ability to watch for these different things occurring. Our timer class is now mostly complete. The last thing we need to do is make sure that we can somehow emit these events or otherwise tell the outside world that something important just happened inside of our timer class. So we're going to add in the ability to detect whenever the timer starts, whenever we tick down a second, and whenever the timer is complete as well. So in other words, our time remaining hits 0. There are many different ways that we can actually implement these things. So we could actually emit an event from our class, but we're going to take a little bit more straightforward approach. We're going to say that every single time that one of these things occurs, we're going to call a callback function that can be provided to our timer class. So that's how we're going to essentially notify the outside world. Let's write out a little bit of test code really quickly, and as soon as we do, I think you're going to get a better sense of what we're going for with this. Okay, so back inside of my editor, I'm going to go down to the bottom where we create our instance of the timer class. So right now, our timer class takes 3 arguments: duration input, start button, and pause button. We're now going to pass in a 4th argument to this thing as well. The 4th argument is going to be totally optional, so we can use our timer with or without the 4th argument, and we're going to need to make sure that we write our code out to accommodate that. And inside this object, we're going to pass in a series of different callbacks that we're going to make sure get invoked at very specific times during our timer's lifecycle. So the 3 different callbacks that we're going to pass in, and again, we're going to make sure that these are all optional, are going to be on start, on tick, and on complete. So if we provide these callback functions, we're going to make sure that our timer calls each of them at some appropriate time. And so this is how we're going to essentially hook up our timer to the outside world and allow us to kind of react to the timer starting, to a second ticking down, or to our timer completing as well. This right here is what is going to allow us to really kind of segment or isolate the different parts of our code base. So isolate the timer from the logic that actually updates the border animation. And remember, that was the entire idea that we spoke about over here, where we had said, oh yeah, the timer would be really messy if we mixed in all the border stuff. So this is how we're going to emit these little events, or essentially signal to the outside world that, hey, timer just started, timer just ticked down, and timer is complete. And so eventually, in these different callback methods, we'll add in some code to update that border animation. And we could potentially add in some other code inside of each of these to do other stuff as well, like maybe play a sound when the timer is all complete, or play a ticking sound whenever onTick gets called, and so on. So in order to demonstrate how each of these are going to work, let's first just focus on onStart. So we're just going to think about onStart for right now. So I'm going to say that whenever our timer starts, I want to do a console log of timer started. So we need to make sure that this onStart callback that we are providing to our timer is going to be invoked the instant that we start up our timer. So in order to do so, we need to first go into our timer implementation. We're going to first update our constructor function and have it receive this object that has all these callbacks inside of it. So let's do that right away. So I'm going to go up to my constructor. So our constructor is now going to receive a fourth argument. So we're going to receive that as callbacks. Now I want to make sure that my timer class is still going to work even if that object is not provided. So the base implementation of our timer, like just to get a basic timer that works, we're going to make sure or require that we get the duration input, start button, and pause button. But we're going to say that you do not have to pass in a set of callbacks at all in order to get the timer to work. Now, for the purposes of this application, there's not a good reason for that. I just want to show you how we would write out this code to say, oh yeah, the callbacks are optional. So to make sure that we have some optional fourth argument here, we're going to check and see if callbacks was provided. So if we call our timer with only 3 arguments now, just those 3, we would fail this if statement because callbacks would be undefined. But if we did pass in an object representing our set of callbacks, then we will enter this if statement. So inside the if statement, we'll put a little bit of code to process the callbacks that were just passed in. So I'm going to say this dot on start is callbacks dot on start. So we're going to essentially just save a reference to the callback that was passed in. So now anytime that we start up our timer, we're going to call this onStart function that we just saved the reference to. Now we are going to eventually come back to this little if statement and handle the other 2 callbacks as well, but like I said, right now we're just focused on onStart. Okay, so we've now got a reference to the onStart method. Now we need to make sure that we call it at some very specific point in time. So inside of the start function, this is where we should probably call that callback and signal to the outside world, hey, timer is starting right now. So right before tick, I'm going to first check and see if this dot onStart is defined. Because remember, it is entirely possible that it won't be defined. If we didn't pass in any callbacks, then we never assigned anything. Like that never occurred right there. And so if we tried to just directly call this dot onStart, we would get an error saying something like undefined is not a function. So we do have to see and just do a quick check to see if we were given an onStart callback. If we do have it, then we're going to go ahead and invoke it inside of here. So I'll say this dot onStart. Okay, and that's pretty much it. So that's just onStart. Let's do a save right here. We're going to go back over to our browser and test this out. So I should be able to click on Start, and the instant I do, I should see timer started. Well, that's pretty much it. So that's how we're going to communicate to the outside world that something just occurred, or something important just occurred inside of our timer. So now that we've got the onStart wired up, we'll take a quick pause, come back in just a moment, and we will wire up the other 2 callbacks as well, so onTick and onComplete. Our onStart callback is all done. Let's do the same for onTick and onComplete. So inside of onTick, I'm going to put in a quick console log and say timer just ticked down. And then inside of onComplete, I'll do a console log and say timer is completed. So now we need to receive these inside of our constructor as well. We're going to assign them to an instance variable and then eventually invoke them during some very specific point in time of our timer's lifecycle. I'll first go back up to the constructor. Once again, inside of this callbacks check, we'll do this dot on tick will be callbacks dot on tick. We'll also do this dot on complete and store a reference to callbacks dot on complete as well. Okay, so we've now stored a reference to both of those callbacks. So now we need to make sure that we call both of them at some very specific points in time. So we would need to take a look at our code and figure out where the most appropriate time is to invoke those callbacks. Well, I think that in the case of on tick, where we want to call this thing every time we tick down our timer, chances are the most appropriate time for that would be like right here inside the else case of our tick function. So inside the else case, that means that we are going to like tick down the timer. So for that, right after subtracting, I'll say if this dot on tick. So if we were given that callback, let's go ahead and call it. So now we can repeat the same process for on complete as well. Where would be the most appropriate time to call this? We want to call that function anytime that the timer is done. So in other words, when it has reached 0. So for that, we might go down to tick once again. And right after calling this dot pause, we could do a quick check, see if this dot on complete was provided. And if it was, once again, we will call it. Okay, so this is looking pretty good. So let's now save this. We're going to do another quick test inside the browser. And we're going to take a look at our console and make sure that these console logs show up at all the appropriate times. So we should see a console log occur when our timer starts. We should see some tick messages as the timer counts down. And we should see one on complete when the timer is all done. Okay, so I'll go back over. I'll refresh. I'm going to change this down to just 3 seconds again. I'll hit start. And I see timer started, tick down, completed. Excellent. That is exactly what we want. So once again, these little console logs right here, these are proof that we can essentially tell the outside world, all the code outside of our class, that something important just occurred. And so again, we're going to eventually take a look at those callbacks, and we're going to add in some code to draw the border, to update the border, and eventually reset it as well. So that's pretty much it for our timer implementation for right now. We are going to have to come back to this once again in just a little bit and add in one little more piece of code, but we'll get to that in just a little bit. So let's take a quick pause right here. We're going to start working on all this animated border stuff in the next video. Well, our timer is all done for right now. I said at the end of the last video that we're going to start working on the border. There actually is one last very quick thing I want to do. Right now, our index.js file has a lot of different code inside of it. So it has our timer implementation at the top. It then has some query selectors, and then where we actually create the timer as well. Just to clean up our project a little bit, I would like to extract the class definition for the timer into a separate file, just so that our index.js file is a little bit easier to read. So to do so, inside my root project directory, I'm going to make a new JavaScript file called timer.js. I'll then go back over to my index.js file. I'm going to select the entire timer class, so I'm going to highlight the entire thing. There we go, all the way to the bottom of the class definition. I'm going to cut it. I'm going to go over to timer.js and paste. And I'll go ahead and save it. And then finally, I'll go back over to index.js, just do a little bit reformatting just to make it look nice. And the last thing we need to do is open up our index.html file. We're going to make sure that we get a script tag for the timer.js file that we just created. So inside of index.html, I'll find my script tag. I'm going to copy it, paste a duplicate, and I'll make sure that the top script tag is going to get our timer.js file, because we need to run timer.js before we can safely run index.js. So the first one right here, I'll make sure says timer.js like so. All right, let's save all these files, save all the changes we just made. We'll just do another quick test just to make sure everything still works. Yep, no errors. That means everything is good to go. Okay, well this looks pretty good. So another quick pause right here, and we'll actually start working on that border in just a moment. All right, time to start working on the animated border that is going to go around the timer. Now at this point, I've really just showed you this circle and said, oh yeah, like the border is going to fill up or something like that. That's not really a really good explanation. So I'm going to show you the finished product of what we're trying to actually build here. So here's what we're going for. I want to show a full border around our timer. And then whenever we click on that play button, we're going to essentially kind of empty the thing out until it gets all the way down to 0 like so. So that's the goal. We'll refresh and do it one more time. Yeah, there we go. So that's what we're trying to build. Now I've got some good news and bad news for you. The good news is that, well, we could definitely do this. Like that is within the realm of possibility. We can figure out how without any library or anything like that, we can show that kind of animation. The bad news, there's always bad news. The bad news is we cannot make this kind of animation right here using just CSS borders alone. So if you're used to using borders with CSS and normal styling, unfortunately, we cannot use that to do an animation like the one you just saw. So to do the animation, we're going to instead have to learn about a little side topic called SVG elements. SVG stands for Scalable Vector Graphics. This is going to be a set of HTML elements that we can use to draw kind of arbitrary shapes on the screen. In this video, I'm going to give you a quick demonstration of an SVG element, and then we're going to take a look and understand some of the rules governing them, and eventually understand how we're going to use an SVG to make that kind of animation we just saw. Okay, so here we go. We're going to flip over to our index.html file. SVG elements are HTML elements, and so for this demonstration, we're going to write out some HTML inside of here. Right above my input element, I'm going to add in an SVG with a height of 200 and a width of 200. Then inside there, I'm going to place a circle. Now, of course, I'm going to tell you what all this stuff is in just a moment, but for right now, just a quick demonstration. My circle element is going to have a property of r equals 20, cx equals 30, and cy equals 30. Okay, so there's the HTML markup that we just added in. Let's then save this. We're going to go back over to our browser, refresh, and then lo and behold, we see a circle appear on the screen. So kind of humble beginnings here, so to speak, but this is essentially the technique or strategy that we're going to use to get that fancy border to show up. All right, so now that we can plainly see that there's some kind of circle and we can draw kind of like arbitrary shapes here, let's pause. We'll come back in a moment, and I'm going to give you a lot more details on how SVGs work and how we're going to eventually use them to do that animation. We got an SVG to show up. Let's now take a look at a couple of diagrams and understand how we work with them in general. Okay, here we go right here. So first things first, whenever we want to show a SVG, or essentially some set of random shapes that we want to draw onto the screen, we're going to place an SVG element. When we create an SVG element, we're going to assign it a height and a width. So you can see that we did that back inside the markup that we just put together right here. So when we wrote that out, it essentially created a big square inside of our HTML document that was 200 pixels tall, 200 pixels wide. This SVG element is kind of like a canvas of sorts. And on this canvas, we can draw different shapes. We can very easily see the SVG element in action if we go back over to our index.html file, use our element inspector, and then hover over the SVG. So we can very easily see the full span of the SVG now. So again, this is kind of like a canvas of sorts, or kind of like an area we can draw as much stuff as we want to. The SVG element has a couple of interesting properties around it. One of the most important things we need to understand is the axes that it has, or those dimensions. So the top left corner of the SVG element is what we refer to as the origin. We're going to be working with a lot of coordinate pairs, so like x, y values, in order to place and size different shapes inside the SVG element. All the coordinate pairs that we are going to work with use the origin of the top left-hand side. The x-axis then increases from left to right, and the y-axis increases from top to bottom. So if we were to try to show some different points on here, a point right here might be at about 175 pixels along the x direction. So that means we go over 175 pixels from left to right, and then 20 pixels in the y direction. So that means we go down from 0 to 20 in the vertical direction. Then down here, this would be 190 pixels over to the right and 190 pixels down. So again, origin is always at the top left, and we have our x-axis running from left to right, and the y-axis goes from top down to the bottom. So we're going to very rarely, for our application anyways, have negative x or y values, because negative x or y would mean that we are trying to place a point outside of our available area of the SVG, so like out over here. And that would not display inside the SVG. For something to display, it must have an x and y coordinate within the bounds of our SVG. Right now we've got 200 pixels wide and tall, so in other words, anything that we want to show up must be placed within 0 to 200 on the x-axis and 0 to 200 on the y-axis. So that's a little bit more about SVG elements in general. Now inside of an SVG element, we can place a variety of different other elements, such as a circle. And as you would guess, this is going to draw a circle out onto the screen. There are several other shapes we can place as well. So we can do a polygon, which is essentially a shape with an arbitrary number of sides. We can do a circle, which is what we just did. We can draw an ellipse, or a square, or otherwise a rectangle. We could also draw a path, which is essentially a line that has some arbitrary kind of direction to it. So we can draw out a path that kind of like curves and twists around as much as we please. For our application, as you probably guess, we're going to end up drawing a circle. So we're going to draw a really big circle, like so, and we're going to place our timer text, so like the countdown thing, that text input, all that kind of stuff is going to be placed inside of this circle. Now the circle itself, there are a couple different properties we need to understand. These are pretty basic properties. So r is the radius of the circle. Remember, a radius is from the center point out to a edge. That is separate from the diameter, which is the full distance from one edge to the opposite edge. So in this case, we created a circle with a radius of 20. The cx and cy values are the center point of the circle, or where to place the circle on the SVG. So in our case, because we said cx and cy of 30, that meant that we could go back over to like this diagram right here. So we went over 30 units and then down 30 units. And then we placed our circle, the center point of it, at that location. So you can imagine 30 might be like right there or so. And we can see that is plainly what happened inside of our drawing over here. Okay, so that's some more about drawing a circle. So now if we want to, we could easily play around with some of these r values and cx and cy. So for example, I can move my circle to the right by increasing the cx value. That is going to increase the x value, or the center point of the x value for the circle. So I'll go to like 130, and now I'll expect to see this thing shift over by 100 pixels. Yep, there we go. I'm going to revert the cx to 30, and I'll try increasing cy to 130 as well. So that should move our circle downwards by about 100 pixels. Yep, definitely happened. And then of course we can start to increase the r value. So we could go up to say 120. And now the radius of our circle is going to be significantly larger. So now the circle is so large that it actually flows off the SVG. If something is outside the SVG, it means that we just plain can't see it. So even though the circle is technically off the edge, well, we can't really see it because the SVG itself is going to clip that. Okay, so that is the SVG and the circle. Now last thing I'm going to do, I'm going to revert the circle back to an r of 20, a cx of 30, and a cy of 30. And then I'm going to copy paste this circle down twice. Then on the second one, I'll change the cx to 130. And on the third one, I'll change the cy to 130 as well. And so now I can see very easily 3 circles on the screen. So for us, we're just going to show one circle, but I just wanted you to know that we could show as many shapes inside of an SVG as we wish, within reason, of course. Okay, so I'm going to reduce this back down to just one circle like so. All right, so we now understand some of the basics around drawing a shape inside of an SVG and some properties around SVGs as well. But now we need to understand how we can actually draw something like, well, what we were going for before. This thing over here where we only see the outline of a circle. In addition, we want to make sure that we can kind of like have a line of sorts that goes around at the same time. So we still need to understand a little bit more about how we're going to achieve that. So quick pause right here and I'll see you in just a minute. We now have a bit better idea of how an SVG element works along with circle elements. So now in this video, I want to tell you a little bit more about circles and some special properties around them. And this is going to start to help us understand how we're going to finally implement that animation. Okay, so a couple things I want you to understand about circles. When we draw out a circle using an SVG element, there are really two parts to the circle. The inside of the circle, or kind of like the content inside, we refer to as the fill. The border going around the outside the circle, rather than calling it simply a border, we instead call it a stroke. We can change the color of the fill and the stroke by adding in some additional HTML properties to our circle element. We can also change the width of the stroke or the border as well at the same time. So let's go back over to our HTML file. We're going to start to play around with these different properties a little bit and see what effect it actually has on our circle. Okay, so I'm going to go back to my HTML file. I'm going to first change the dimensions of the circle just slightly so we can see these changes to the fill and stroke a little bit more easily. So I'm going to increase the radius to 90. I'm going to take my CX to 100 and CY to 100 as well. Now let's save this and refresh our app just to see the effect it has. Okay, so that's what it looks like now. Now, quick reminder, just really quickly, remember I run my browser very far zoomed in, so you probably see something a little bit closer to that right there. Okay, so let's try changing the fill and the stroke. I'm going to first give myself a little bit of space to work with, because we're going to eventually add in several different properties here. So I'm going to put in a fill of red and a stroke of blue. I'm also going to set the stroke width property as well, so stroke dash width, and I'll pass in 10 for that. So this means make the center of the circle blue, or excuse me, make the center of the circle red, make the border blue, and the border should be about 10 pixels wide, or 10 pixels thick. So let's save this, go back over, and see what happens. Well, yep, that's pretty much it. So now we've got the red interior, the blue exterior. If we start to increase the stroke width here to say like 50, the border is going to get that much larger. I'm going to stick with 10 for now because it's a little bit easier on the eyes. Now there's another very interesting value for fill that we can use for our application and is really relevant to what we are trying to do. For the fill, we can specify a color of transparent, which means make the center of the circle see-through. So if we use a fill of transparent, that means we could very easily start to see some timer elements behind this thing or something like that. So I'll set fill to transparent, and now the center totally gone, and I can see directly through it. Okay, so that's some basic additional properties around a circle. Now there's a couple more that are going to help us modify or play around with that stroke. So let's take a look at a couple more diagrams and understand what these other properties are that are going to allow us to modify the border around the exterior. So the first additional property I want you to understand is stroke dash array. We're going to give this a number value, and it's going to specify the length of a dash around the perimeter, or essentially for the border of the circle. Let's try adding in this property and playing around with it just a little bit. So I'll go back over to my HTML file, and I'm going to add in a stroke dash array. And I'll start out with 10. So that means give me a dash border, and I want each segment of the dash to be 10 pixels long, and then a 10 pixel gap before the next dash segment. So I'll save this, go back over and refresh. So this means, or I can see very easily now, I've got about 10 pixels of dash, and then a 10 pixel gap, then 10 pixels dash, 10 pixel gap, and so on around the exterior. This dash array property technically accepts two different values. If we only pass in one, then 10 will be used for both the different values. The first value we pass in is going to be the length of the dash, and if we pass in a second, it is totally optional. It will be used as the spacing in between each dash segment. So for example, if I put in a 10 and then a 5, that means give me dash lengths of 10 and then spacing in between each of those dashes of 5. So we can save this, go back over, and now we'll see we've got about 10 units of dash and 5 units of spacing in between. But again, if we just put in the one number, that means give us identical dash lengths and gaps as well. So I'm going to leave it at 10 for right now. Okay, so this looks good. I want to remind you of something about properties of circles in general. So if we take a circle and we measure its radius, so that's going to be from the very center point to the outside edge, we can calculate the entire perimeter of the circle, so the total length of the outside edge, by using the formula 2 times pi times the radius. Now the radius that we just changed our circle to is 90. So if we do 2 times pi times 90, we end up with 565. So that means that the total length of the outside edge of the circle is about 565 pixels. So with that calculation in mind, we can start to draw like a quarter or like a half segment of border around the circle. Let me show you. In my terminal, I'm going to calculate 2 times math.pi times 90, and then divide that by 2. So that gives me about 282. So if we enter in a dash array of 282, that means that we want to have about half the circle have a dash, and then have half the circle not have a dash. Okay, so I'm going to go back over and try updating the dash array to about 282. So if I now save that and then refresh, there we go. So I've now got half the circle with a dash, half without it. We can do something very similar. So 2 times math.pi times 90, and then this time I will, how about multiply by 1/4, so 0.25. So now I would have just a quarter segment if I use that 141. So now I get a quarter, half a quarter of no dash, half a quarter dash, half a quarter of no dash. And then of course, the last thing I want to show you around this perimeter is that if we do the full 565 or just slightly less than it, that should give us just about the entire length of the thing and then leave us just a little bit of a gap. So I'll do right around 560 and just leave a little bit of a gap. So now I can see I get a whole bunch of border and then just a tiny little gap at the very edge. So the next thing I want to tell you about this circle is that the border is always started drawn from the right-hand side, and then it draws around clockwise. And we can see that very easily with the border dash array, or the stroke dash array that we just added on. So it's very clear that the border starts right there and then travels around clockwise until it decides to hit an empty spot. We can start to play around with that value of dash array. So I'm going to change it really quickly here several times. So I'm going to start to decrease it to say 550. And I can see that the gap is a little bit larger. I can go to 520, a little larger. I can go to 480, a little larger yet. Okay, so that's how we can get like a just about full border, but have a gap at the very end. So now there's just one last thing I want to show you. I'm going to change the dash array back to the full about 560 or so. The last property I want to show you is called the dash offset. Now the dash offset is a really tricky property to understand. Suffice it to say, if we have a border that goes just about around the entire outside edge, dash offset will introduce an extra little spacing right there. Let's play around with dash offset just to get a sense of what's going on with it. So back on my circle element, I'm going to add on stroke dash dash offset, and I'll start it off at 10. So this means in addition to that little space we have right there, give us another extra 10 units of spacing as well. So that's going to give us a little 10 extra units of a white space right there. So I'll save this, refresh, and I can clearly see 10 extra units, or about 10 extra units. I don't actually know what 10 units looks like, but hey, there's 10 right there. So now if I start to increase that value to say 20, okay, some more. If I go to say 40, I get more yet. If I go up to 100, okay, 140, that should be about a quarter. And then if I go to about 80 or so, 282, that's going to be about half, and I can eventually essentially unravel the entire thing by specifying about 560. And so that's going to give me extra white space all the way around that outside edge, back to around right there. Okay, so the dash array and the dash offset properties are how we're going to actually pull off this animation. So let's take a pause right here. In the next video, we're going to take another look at these properties, and I'll explain exactly how we're going to use them to actually show the animation on the screen. Now that we understand the dash array and dash offset properties, let's understand how we're going to use them to actually implement this animation. I want to first begin by taking a look at the finished product one more time. So this is what we are going after. We want to have the entire stroke starting off as covered. So that would imply that we're going to begin with a dash array with whatever our perimeter value is. So for us, it's right around 565. And we should also have a dash offset starting at 0. So that's how we're going to get that full arrow, or that full border, excuse me, starting up when we first start our application. Now here's where things get challenging. Take note of how this animation plays out. We're starting from the very top edge, and we're going to show white space going in the clockwise direction. That's kind of counter to what we were just discussing. Remember, the default behavior is to draw the border starting from right here, as opposed to anything up at the top. And then the dash offset is going to add in additional white space going in the counterclockwise direction. So this final product has the spacing, or the white space, going in clockwise. What I just showed you around dash offset is going to add space in the counterclockwise. So in other words, if we use dash offset as we know it right now, and we start off at 0, and then let's say 1 second goes by and we change that to 20, okay, we're going to get that gap. Then if we go to 40, we're going to get that gap, and so on. So again, it is playing in the opposite direction of what we really want. So how are we going to fix this? Well, as usual, it's just a little trick. Dash offset, we're just going to make it negative. Yep, that's pretty much it. Providing a negative value of dash offset is going to add in that white space in the opposite direction. So it's going to start to go in the clockwise direction instead of the counterclockwise that we saw in the last video. So if I change dash offset to negative 40, we're going to get the white space right there. And then as we start to take that number more negative, it's going to start to go in the clockwise direction. We're going to see more and more white space, like so. So we can imagine that for every second that goes by, we're going to change dash offset to be slightly more and more negative. And that's what's going to give us white space going all the way around the outside edge until it eventually comes back to the same right-hand side. So now the last big question is, how are we going to actually get the animation to start at the top, like up there, as opposed to the default behavior, which is to have the entire border being drawn right there on the right-hand side? Well, once again, a little trick. It's usually how it works out. So the little trick we're going to use, we're just going to rotate this entire circle negative 90 degrees. So we're going to take the entire circle, rotate it negative 90. So we're going to take it 90 degrees in the counterclockwise direction, counterclockwise. To do that rotation, we can add on an additional property to our circle element. We're going to provide transform is rotate negative 90, and then this will also take two other arguments when we call rotate. We're going to pass in 100, 100, 100. Let me expand this just so we can see it more easily. So as you would guess, the first argument to rotate is going to be the amount we want to rotate and the direction that we are rotating in. A negative value means that we're going to rotate in the counterclockwise direction. The second two values right here define the origin point of the transform. So by default, usually a transform is done against the top left corner of our SVG element. By passing in 100, 100, we are saying that we want to rotate this circle around what happens to also be the center point of the circle. So we're going to rotate around that point right there. So let's save this, refresh. And now if we start off with a dash offset of 0, we start up right there, everything's matching up on the top. And then as we start to make this number more and more negative, so I'll go to negative 10, it's going to start to give us that white space. As I go to negative 50, give us more. As we go to negative 100, and we can start to see how as we start to make dash offset more and more negative, we're going to get that white space around that outside edge going in the clockwise direction, just like we saw on our finished product over here. So that's pretty much it. That is the secret. The secret is to use the negative value of dash offset. We're going to use a dash array value equal to the entire perimeter of the circle. And then finally, we're going to transform the circle as well to implement a rotation negative 90 degrees. Okay, so now that we see like the general idea, essentially what we're trying to do here, the last thing we have to do is essentially take this entire strategy. We need to make sure that every single time we tick our timer, so like over here with on tick, every single time that happens, we need to make sure that we start to make dash offset right here more and more negative. We're also going to add in a little bit of code to kind of adjust these values of dash array and like calculate that value on the fly. Because obviously putting in the parameter, or excuse me, the perimeter right here, that is a calculated value. We have to do 2 times pi times the radius. So rather than encoding the dash array right here, we'll instead set that programmatically. So we'll read the value of the radius of the circle, calculate the perimeter, stick it in, and then every single time we get a tick, we will update dash offset. So now that we've got the full story, quick pause right here, and we'll work on our implementation in the next video. Now that we've got the entire story, let's start to work on the actual implementation of this animation. The first thing we're going to do is change some of the dimensions of the SVG and the circle element. Right now, if I zoom all the way out to 100%, that timer that we have right here is really small. So I want to basically double the size of the timer just so it fills up the screen a little bit more nicely. So to get started, I'm going to find my SVG element. I'm going to change the height to 400, the width to 400. I'm going to change the radius as well. We're going to use a radius of 190. We're going to leave the CX or in CY at 200 and 200, but we are going to have to come back and adjust those in just a little bit. You'll see why very shortly. We will leave the fill of transparent. The stroke I'm going to leave as blue. I'm going to slightly adjust the stroke width, make it just a little bit thicker at 15. And then finally, I'm going to take out the dash array and the dash offset. We're going to calculate both those values on the fly using the radius. Because otherwise, like I just mentioned, if we ever decide to change the radius again, chances are we might not remember how dash array is calculated. Remember, it's supposed to be the perimeter value. So we're going to calculate that value on the fly using the radius, just so we don't have to remember, oh yeah, 2 times pi times the radius to figure this out. So in total, we're going to double check here. We should have R, CX, CY, fill, stroke, stroke width, and transform. Oh, one last thing, I apologize here. On rotate, we need to adjust that to 200, 200 to specify the new center point. Okay, so let's save this now and see how we're doing. Okay, well, that looks pretty good. Definitely a little bit better sized. We're going to make sure that the text input and the start and pause buttons eventually show up inside there, but let's just work on the animation to get started. So we're now going to go back over to our index.js file. And down by our timer, we're going to eventually write a bunch of different code inside of here to work with the timer and make sure that every time we get a tick, we kind of clean up a little bit or really kind of change some of the different properties of that circle element. So to get started, at the very top with all these other query selectors, I'm going to add in a selector to find that circle element. So I'll say const circle is document.querySelector circle. Then after that, we will immediately read off the value of r, or the radius, and we'll use it to calculate the perimeter. To find the radius of the circle, we can use circle.getAttribute, and then we put in the name of the attribute that we want to find, in this case, r. So to calculate the perimeter, it will be the radius times 2 times math.pi. And notice how pi right here is all capitals. So I'm going to assign that to a variable that I will call perimeter. Then immediately after that, we're going to set the dash array value on the circle equal to the perimeter. Remember, that is what is going to get us the full big circle like you see right here. So I'll say circle set attribute, and we're going to try to set stroke dash dash array. And we're going to set it equal to the perimeter. Okay, so that looks pretty good. So now the next thing we're going to do is to make sure that every single time our timer ticks, we're going to once again set an attribute, but this time we're going to set our stroke dash offset property, which is what's going to give us that white space up here on the starting on the top edge and then go around in the clockwise direction. So inside of onTick, I'm going to delete that console log, and I'll replace it with circle.setAttribute. We're going to set the stroke dash dash offset property. And we need to provide a value right here that's going to start off as 0 and go more and more negative over time. Ideally, by the time our entire loop finishes, so by the time the timer ticks down to 0, the stroke dash offset right here should be equal to the perimeter. That would be ideal. So to make that happen, for right now, we're going to declare a little variable right above our timer that we'll call current offset. And I'll initialize it at 0. Then inside of the set attribute, or inside of the onTick right here, I'm going to say current offset And during every tick, we'll update the value of current offset. So we'll say current offset will be current offset minus 50. And I apologize, I actually want that line to be underneath the set attribute, like so. So we'll set the attribute and then subtract a little bit off the current offset. Okay, so let's save this and see how we're doing right now. So I'm going to flip back over. I'm going to refresh. I'm going to hit start. And now we can see that things starting to tick down. Well, look at that. It actually works. Okay, well, that's definitely not bad at all. The only problem right now is that it is a very kind of like blocky animation. Because remember, we are only ticking once every second. And then every second, we are counting off by exactly 50. So that's what's resulting in this really blocky looking animation. The other issue is that as soon as we start to get down to right there, well, unfortunately, because we are just subtracting 50 units every time, we're going to eventually roll around that entire property or that entire value of stroke dash offset. So it's going to eventually get greater than the perimeter. So definitely what we have right now works, but there are a couple things about it we need to improve. So we need to make sure that the animation is a lot smoother. We also need to make sure that rather than using this just negative 50 right here, we should adjust by a very even increment. So essentially the number of ticks, or really our perimeter, divided by the number of ticks. So that by the time it gets down to 0, or the timer gets down to 0, we should end up right there and not go over to the next edge. So definitely still a little bit of work. So let's get started on that in the next video. Well, we've got our animation working, but there are two big issues with it. Right now, whenever we run the animation, it's occurring in this real kind of like block segment, second by second. So it'd be really nice to have a much smoother animation. The other big issue is that because we are always subtracting by 50 units for our offset value, we're always going to end up either overshooting or undershooting, having the animation finish at the very top point right there. So take a look at this. I'm going down to 9, 8, 7. Ideally, the animation would stop right there. And even not even really right there because we still have that little segment visible. For the animation to be really correct, the entire border should disappear right when it hits 0. So again, we need to make sure that we somehow get a better subtraction right here than the negative 50. Let's first focus on the animation, however. So let's make sure that we can show a really smooth animation as opposed to the big blocky thing. To make the animation a lot smoother, we can just choose to run our timer much more frequently. So let's take a look at our timer implementation once again, back inside of our timer.js file. If you take a look at start right here, you'll recall that we are running the tick method once every 1 second, or 1000 milliseconds. So what we could do to make our animation a lot smoother is run the tick method way more frequently. And every single time we run the tick method, rather than doing the 50 unit update right here, we could do a really small update, like 1 pixel. So if we only do 1 pixel update at a time, it will make the animation a lot smoother. So to make this happen, let's go back to timer.js. We're going to find where we set up our interval. And rather than running tick every 1 second, we'll instead run it every 50 milliseconds. So that's going to be way more frequent. Now let's make sure down inside of our tick method as well, right here where we update the value of time remaining, rather than subtracting 1 second, because we're going to run tick so much more frequently, we should instead only subtract 0.05 now. So that's 50 milliseconds. It matches up perfectly with the interval timer that we have right there. Okay, so let's now save this. I'm going to go back over to my index.js file. I'm going to find where we've got the 50, and I'm going to change that to 1 instead. So now every single time we have a tick, I'm going to update the current offset by just 1 unit, or 1 pixel. So I'm going to save this. I'm going to go back over, refresh, and hit start again. And so now we can very easily see that the animation is a lot smoother. But there's another little issue that's cropped up. Take a look at the text input right here that shows the current value of the timer. It definitely has the like 17 point whatever. It looks like it's counting down, but you'll notice that there are a ton of extra 9s inside of here. So how could that be? We are only ever adjusting the timer by, over here, 0.05 units. But for some reason, we're getting all these extra 9s inside there. Well, the reason we're seeing this is because mathematics in JavaScript is a very imprecise science. All the subtraction, addition, multiplication, all the stuff that we do uses a system in JavaScript called floating point operations. And math inside of JavaScript sometimes gets subject to these really strange rounding errors. Well, let me show you a really common, very easy to reproduce rounding error inside my console right now. I'll say 1.9 minus 1. Yeah, didn't really see that coming. So of course, the result of that should be just zero point 0.9. But because of the way JavaScript handles math, and actually, to be honest, most programming languages handle math, we end up with this really weird result. And so because of this floating point error, that is the same reason that we're seeing something really funky inside of our input right there as well. So we can fix this up pretty easily. We're just going to do a little kind of a rounding operation when we set the value inside that input. I'm going to go back over to my editor, find the timer.js file, and I'll find our setter method for time remaining at the bottom. So here's the setter. So we take the current time that has been passed into time remaining and throw that into the value, or the input value property. So it's this time variable right here that has all those extra decimal points inside of it. So to make everything work out nicely, we can just call toFixed on this. That's going to essentially round the decimal on there to just 2 decimal places. So we're going to drop off all those extra little values that we see inside, or all the extra little decimals. So I'm going to save the update, go back over, refresh, hit start again. That's definitely better. So now we just see the first 2 numbers and the first 2 decimals. Okay, so overall, I'd say that this was a good fix. So now the last big thing we have to do, inside of our index.js file, subtracting by 1 right here, still not appropriate. We need to make sure that we adjust the current offset by some appropriate value so that no matter what our timer is running for, we will always end the animation at 0 seconds, perfectly at the very top of the circle. So we'll have to figure out some way of handling that. Let's take a pause right now and discuss how to do it in the next video. The next thing we have to do is to make sure that we adjust our dash offset value by something more precise than -1. So let's take a look at a couple diagrams and really understand the math that we have to do. Okay, so here's the general idea. When everything first starts in our side of our animation, we want our dash array value of our circle element to be equal to perimeter. That is what is going to give us that big round circle when everything first starts out. When the animation ends, we still want the dash array to be equal to perimeter. But what's really going to change over time is the dash offset. The dash offset will start off at 0, so that's what's going to give us the kind of nice circle right here. And then over time, we want to make it more and more negative. As the dash offset gets more negative, we're going to get additional white space from the top going around the clockwise direction. So by the end, we want to have a dash offset equal to -1 times perimeter. So the real question here becomes, how do we start with a dash offset of 0 and then effectively over the span of our entire timer and in very equal increments go from the value of 0 to negative perimeter? Well, to make that happen, we're essentially going to say if our perimeter is, say, a circle of 100 units, and we have total 50 different tick events, then each individual tick would need to adjust that offset by -1 times 100 divided by 50. That gives us -2. Well, let me show you a better diagram to really illustrate how this formula works. So here's the formula that we need. So we're going to calculate offset. This is going to be how much we're going to change that stroke dash offset property for every tick. So that's the general formula. We can start to plug in the start and end values inside of it to figure out or make sure that it actually makes sense. So our offset at the very start would be p times the time remaining, which would for us be 30 seconds, divided by the total duration, which would also be 30 seconds. And then we would subtract by the perimeter. The 30 divided by 30 would turn into 1, so we would end up with p minus p, and so offset at the very start would be equal to 0. And so that matches up with our initial requirement over here. Then at the very end, our dash offset is equal to 0, or our dash offset we want to be equal to negative perimeter. So at the very end, we're going to have a time remaining of 0 divided by 30. So we get 0 divided by 30. That's going to end up zeroing out, and we are left with just -p. And that once again matches up with what we just discussed over here. So this is pretty much the formula that we have to implement inside of our onTick function. There's just one problem with it. Our onTick function doesn't really have any idea of how much time is remaining or the total duration. That's not a big problem, kind of. Let me show you a real small change that we can make to our code to make sure that the onTick function that we have, so this function right here, can get access to the time remaining. If we want to do that, we could go back over to timer.js. I'm going to find my tick function. Here it is right here. inside there I'll find where we call onTick. And inside of it, when we call onTick, I will simply pass in this dot time remaining. So now back inside of our index.js file, onTick is going to receive the time remaining. So that's not bad. So we now have one of the values inside of our formula that we need to determine what the offset should be at each tick. Now there is a second problem here, and that is the total duration value. We need to know the entire duration of the timer. So if we set it for 30 seconds and hit start, we need to know that starting time. Right now, there is absolutely nothing inside of our application to track that value. In other words, there's no input, there's no value inside of our timer class, nothing that tracks the total duration of the timer. But by using one of the callbacks we implemented, we can start to track it ourselves. So we're going to say that whenever we call onStart, we're going to pass in an argument that represents how much time is going to take for this entire timer to run. We'll then receive that argument right here and store it, so then later on, inside of onTick, we can use that value to figure out what the total duration is going to be. So let's write out some code, because I know this is confusing. Let's write out some code. You're going to see where we're going with this really quickly. So I'm going to go back over to my timer. I'm going to find where we call onStart, which is inside the start function. And when we call it, I'm going to pass in the value of this.time remaining. So when we first start our timer, this.time remaining, that value is going to be how long the timer is going to run in total. So in onStart, we can receive that as an argument that I will refer to as total duration. So then back over here, rather than storing something like current offset right there, I'm going to delete that, and I'm going to make a new variable called simply duration. And then we'll set the value to total duration whenever the onStart function is called. So we'll say duration is total duration. So then finally, inside of onTick, we can actually implement the correct offset when we update the stroke dash offset. So we no longer have to make a change over time. So I'm going to delete that line. Instead, at every tick, we're going to take the time remaining, we're going to take the total duration, and we're going to take our perimeter, and we'll use it to figure out exactly what the offset value should be. So I'm going to delete current offset right there. I'm going to give myself a little bit of space, and we'll write in our formula. So remember, right above, we already defined our perimeter. So we'll say perimeter times time remaining divided by the duration. And then we'll subtract from that the perimeter. And that's it. Now I know this explanation of all the math is really nasty, but when it really comes down to it, this is what's really going on. So I'm going to save this, and we can do one last test. I'm going to make sure I save both files, of course. Flip back over. I'll hit start, and now we can see the timer working as expected. By the way, the animation is always going to play a little bit more smoothly if you close your console. So close your Chrome console if it seems like it's a little bit laggy. So now we can wait for this to count down all the way to 0, and when it hits 0, we should see the animation finishing right there at the very top end point. So 9, 8, 7, well, you can count. So I'm just going to wait for this thing to finish up and make sure that it finishes at the correct location. And there we go. So by the time it hits 0, we have cleared out that entire circle perfectly every time. Now, of course, I can always update the timer to say 3 seconds, hit start, and it's going to play it again. Okay, well, let's say this looks pretty good. Now, the only thing that we might change here, when I use 3, you'll notice it still looks a little bit choppy. So if you want to, you can always go back over and adjust the interval that we do this update at. So instead of 50 right here, we could always take it down to say 20. But if you update it right there, just make sure that you update how much we change time remaining by for every tick. So if we take that to 20, we would want to subtract 0.02 from time remaining. So I'll save this, I'll refresh, I'll try again with 3 seconds. Yeah, that definitely looks a little bit more smooth. Okay, well, this looks pretty good overall. So now the last thing we have to do is just a little bit of styling to make sure that the input, the start and pause button, all that stuff shows up inside of the circle. So let's take care of some styling in just a moment. Now that our timer is working pretty well, we need to apply a little bit of styling just to make sure that everything shows up inside the actual timer. The first thing I want to do is replace the start and pause buttons with the icons for pause or start and pause right there. So to show those icons, we're going to use a free icon library called Font Awesome. I'm going to open up a new browser tab and navigate to fontawesome.com. So this is a free resource that we can use to show tons of different icons inside of our application. The first thing we have to do is wire up this library to our app. To do so, we're going to open up one other page. I'm going to go to cdnjs.com. Once here, we can search for font awesome, and we'll see a link right here. So notice that this is a CSS file. That's how we make use of font awesome inside of our project. We're going to hook it up as a CSS file. So I'm going to copy that link. We'll then go back over to our HTML document. Here it is right here. I'll go up to my head, and I'm going to add in a link tag. So I'll say link. We're going to use a rel of style sheet, and then an href, and we can paste in that link that we just copied. Okay, so now that we've wired up Font Awesome, we can take a look at the Font Awesome documentation and figure out which icon we want to show. So I'll go back over to the Font Awesome documentation. On the top left-hand side is a little search box. So when you first get started with icons, of course, you're probably not going to know exactly what the name of any icon is. So it's really up to you to just kind of take a guess. When I look at these icons, the words that come to my mind are play, for that right there. It's like a play icon, and pause. So I'm just going to take a guess, and I'm going to search for play. And when I search for play, we're going to eventually see some results. Here we go. So these are all the different icons that match that search string. Looks like that one right there looks pretty good. So I'll click on that one to figure out how to use it. Now sometimes Font Awesome's website is really slow, so I'm just going to give this a second to load up. Hopefully it resolves quickly. Okay, very good. So now to actually make use of this icon, you'll see right underneath play is a little I tag right there. So that's the HTML that we're going to show in order to show that icon. So I'll click that thing to copy it. I'll go back over to my HTML document. I'm going to find my button that says start. I'll delete the text that says start and replace it with that I tag. So now I can save this, go back over to my browser, refresh, and I'll see the play button right there. Okay, so that's definitely good. So we could definitely repeat the same process to get the pause icon as well. So I'll search for pause, wait another couple seconds for it to load. Yep, that definitely looks good. So I'll click it and click on the I tag again. I'll go back over to my HTML document, find where we have pause inside the button. I'll delete it and replace it with the I tag as well. Okay, so I'll save this a second time, refresh. Okay, well, that looks pretty good. All right, so for the rest of the styling, I'll be honest with you, it's really just a bunch of CSS and whatnot that we're going to throw into our HTML document. So we're going to take a quick pause right here. In the next video, attached to the video, you're going to find a zip file. Inside that zip file is going to be an HTML document and a CSS file. Make sure you download that zip file. It's going to be called something like timer 025 template or something like that. So make sure you download that zip file and find the HTML and CSS file inside. Okay, so make sure you grab that and we'll start to integrate that or merge it into our project in just a moment. Attached to this video, you're going to find a zip file called timer 025 template with template in all capitals. There are probably two different files attached to this lecture, so make sure you get the one with the name template inside. Once you get that file, we're going to unzip it and then take a look at the two files inside. So we've got an index.html file and a style.css. So all I did here was add in a couple of additional HTML elements, some class names, and some CSS, just to apply a little bit better styling to our timer. The only reason I'm giving you this is that, well, this really is a course about JavaScript, and so for the most part, we're going to skip over a lot of styling stuff. I still want you to have some neat looking apps though, which is why we're usually going to have some HTML and CSS being provided to you. So to use these files, I'm going to open up my editor, and I'm going to first begin by dragging and dropping the index.html file into my editor. So here's the HTML file that we were just given. I'm going to select everything inside of here with a Command or Control A, depending upon your operating system. I'll copy everything. I'm going to go back over to my index.html, so the one that we've been working on for our project. I'm going to select everything inside of here, delete it, and then paste. So now as we look through here, we're going to see just about everything is the same. So we still have a SVG element, we still have a circle, the input, the buttons, and all that stuff, just a slightly different structure. Next up, I'm going to create a new file called style.css. I'll go back over to where we had those two files from the zip file. I'll find the style CSS that we just downloaded. I'm going to drag and drop it into my editor. I'll select everything inside, copy it, and then paste it into the style.css file that we just created, and save. All right, so now that everything is saved and updated, I'll flip back over to my browser, I'll refresh, and we get something that looks like this right here. If I zoom back out to 100%, you'll probably see something that looks like basically that. So now I can click in here to run the timer. It's all the exact same logic that we just had, nothing changed. All the JavaScript code is identical because, well, we didn't change any of it, right? And now I can click on that thing. It is the actual text input there. So I can click on it and change it to, say, 30 seconds, and then run it down. I can pause it, change it again to, say, 60 seconds, run it down, and so on. So that's pretty much it. Now, one thing I want to really highlight is that that really is a text input. The only thing we did with some CSS was make sure that it doesn't display a border, and it also doesn't get highlighted when you actually select it. So if I actually do a little bit of fancy stuff here really quickly, you'll see that there's an outline property being set inside the style.css file of none. So that's why it doesn't really look like an input, but it technically is. All right, well, I hope you enjoyed this project. We definitely learned a lot along the way about SVGs, handling set intervals, classes, where to store information, and all that kind of stuff. We still have a lot of code to write and a lot of projects to work on, however, so let's take a pause right here and start working on our next project in just a moment.